Now, let us assume n experiments have taken place. What are experiments in this case? Observations of a value for realization have taken place, and the outcomes, which is nothing but the realized values or realization of observations, be expressed as x1, x2, xn, where n is greater than or equal to n. It means you pick up a threshold value and only observe when the value is exceeding n, okay? Because x can assume only values of, let us say, x1, x2, xn in the n groups. So, for the observed outcome, let xk be the group value, let nk denote the number of outcomes of this group, then 1 by n summation of j equals 1 to n xj, which is the mean of that value, can be now said as k equals 1 to n, because I am looking for only the n group, okay, and the realized values are xk, and I am going to say I am going to check only within the group and find the mean value. So, the mean is now redefined slightly in a different manner. You can always find the mean for a given variable if you are looking only for the realized values within a specific group. So, this can also be further extended as limit n tends to infinity 1 by n summation of j equals 1 to n xj can be summation of j equals 1 to small n xk pk. We already know this is true because pk is actually, as we saw, is given by this expression nk by n, the probability of that value over the given data. Therefore, in general, the expected value of the random variable, let us say g of x, is given by, we are going for a generic expression now, m g of x is expected value of g of x, which can be given as minus to plus infinity g of x f of xx dx, where g is an appropriate function whose integral exists. That is very important, otherwise you cannot estimate or evaluate this integral. Now, by substituting g of x equals x minus mx square, now I can also find the variance of x, which can be given by variance of x, or also expressed as sigma x square is expected value of x minus mx square, which is again expressed as minus to plus integrity x minus mx square f of xx dx. And we know that sigma x, which is the standard deviation, which is actually the square root of variance, is a good measure of spread or variability of outcomes of x. Further, we can also say sigma x square is again expected value of x minus mx square, which can be said as expected value of x square minus 2 mxx plus mx square, which can be said as expected value of x square minus mx square, and hence sigma x square is limit n tends to infinity 1 by n of summation of j equals 1 to n of x j square minus 1 by n of j equals 1 to n of x j the whole square. Extending this logic, one can also find the coefficient of variation. Actually, this is expressed as Vx. It is actually a dimensionless quantity. This is used as a measure of statistical fluctuations, or what otherwise we call as uncertainties. This is given by sigma x by mx for non-zero mean process. So, interestingly, a small Vx, that is coefficient of variation, means there are relatively small statistical fluctuations around the mean value. So, that is what we understand by expressing or determining V of x. So, friends, let us reiterate the statement which we already made. So, stochastic process is defined as the quantity x of t is called as stochastic process if x of t is a random variable for each value of t in an interval which is designated say a and b. Let us quickly take an example of a stochastic process. Assume x as a random variable. This is assumed to be normally distributed. There are different forms of distribution available in statistics. Mean value of the variable is m and standard deviation is greater than 0. The probability density function PDF is given by, for a normal variate, we know this equation, but still let us write this 1 by root pi sigma exponential minus half x minus m by sigma the whole square. If g of t is a known real function which is defined between the interval minus infinity to plus infinity, that is exists between minus infinity to plus infinity, then g of t cos omega t, where omega is a positive constant, hence x of t is also true as x g of t, which is again a stochastic process defined for minus infinity to plus infinity. Now, realization x of t of this process is actually given by the product of g of t with an outcome x of the random variable x. Mathematically, x of t will be x g of t. Hence, if g of t is cos omega t, then various realization would also be harmonic function of the same period, but with different amplitudes. Hence, the mean of value, which expected value of x g of t is expected value of x g of t, which is nothing but m g of t, and sigma x of t is square root of expected value of x g of t square minus m g of t square, which can be expected value of x square g of t square minus m square g of t square, which can be said as square root of expected value of x square minus m square g of t, which is actually equal to sigma g of t. Therefore, for each given value of t, g of t is constant, that is x of t is x g of t is also normally distributed, because we have assumed a normal variate. This is true if g of t is not 0, and hence the PDF of x of t is given by f of x t x, which is 1 by root 2 pi sigma g of t mod exponential of minus half x minus m g of t by sigma g of t the whole square. So, friends, in this lecture we understood the example of stochastic process modeling. We understood estimating of or estimation of mean value by two different methods. We have also understood certain terminologies. One classical and interesting terminology, CV, coefficient of variation, which is very interesting for us to know the uncertainty or fluctuations, statistical fluctuations around the mean. We also understood that how x of t and g of t can be mapped and to estimate the statistical parameters which are important. So, why we are looking for statistical parameters? Because stochastic analysis is an alternative which uses statistical parameters for analyzing instead of deterministic analysis. In the next lecture, we will take up an example of fatigue prediction, because it is an important application in offshore structures. We will talk about fatigue prediction in couple of lectures and give lot of example problems and also coding, the mathematical coding to estimate fatigue predictions. Thank you very much.